If the students can't come to the duct tape, I'll bring the duct tape to the students. In the last 6 weeks I've been teaching design engineering for physics students, my freshman course in physics at the Delft University of Technology. For 6 weeks every Wednesday, normally 165 students would come into my classroom and they would have to build a device in one day that had to work at the end of the day. But they weren't allowed into my classrooms. So instead we had them build at home. We had sent them starter packages, which included of course duct tape and Arduino, basic electronics that they could use. And over 6 weeks they've made tremendous great devices, and I'm really proud of what I've seen in the last 6 weeks, which is what I want to share with you in this video. The course is structured in such a way that the students through these 6 workshops get to learn a systematic approach on how to apply their knowledge of physics when designing, to make sure that they can systematically analyze what the design problem is, see what physics knowledge is needed, apply it, and at the end of the day have a working prototype of a device. The first thing they needed to do, for example, was design a calibration setup. We would give them a sensor and they would have themselves, with stuff they have at home, come up with a setup that could calibrate that sensor. The second day we made it a little bit harder and we said, okay, now today you have to make your own sensor. The sensor would have to work based on a change in capacitance. They would have to design a way where the outside environment would change their setup in such a way that the capacitance of their setup would change, which is measurable with an Arduino. The third one is an example of how when you have to design for something that is not allowed to fail. Think Mars rover, where you have to analyze and analyze and analyze and simulate, and it has to go right the first time. The equivalent for us was build a transistor on a chip, because chip design is really expensive. So they had to design their own transistor on micrometer scale, and I don't have a picture of what they were doing because they did it all in software. But that doesn't stop us from making it real. Of course, the chips are at this moment being fabricated, and in a few weeks they will get them in their own hands, and then they'll have to measure if their design actually performs as they designed. The fourth day was all about algorithms and learning that, and designing an algorithm is also a design approach that you can do systematically. But we also wanted to make sure that it's very tangible. So using their designed algorithm, they had to do measurements with acoustic distance sensors. And if you look at these little holders, they also had to design them by themselves. They had to send us the design files and we laser cut the wood so that they would have holders for the little sensors that they then used in their assignment, where they worked with an algorithm that they designed themselves. The fifth assignment was all about vibrations. If you're working in a physics lab, you always have unwanted vibrations that you don't want to have interfere with your measurements. So they had to design a way to make sure that a measurement setup wouldn't move if the outside world was moving. And this is a great example of parametric design. The software that we used to test if everything was working was Tracker, by the way, which is great and gets you these kind of movies. The final day we gave them way more freedom so they could show us that in the previous 5 days they had learned how to construct their day, how to approach a design cycle. And the assignment we gave them was make a device that is able, based on the light emitted from a light bulb, to determine if it's an incandescent or an LED light. And we got so many really cool spectrographs that gave spectrums like these. I'm really proud of what these students have made and wanted to share that with you all here. The next step in this course is a final assignment that is way bigger, not just one day. It will run all of May and June. People that have watched this YouTube channel may have a guess about what the final assignment is about. We tweaked it a little bit this year. Stay tuned, and start of July we'll have videos for everyone to see what the students have made in May and June.